Hello guys, so let me share my screen first. Okay, so yesterday we were on this last question from the binary search, median of two sorted arrays, and our approach was failing basically on the uh, basically it passed 2060 test cases, only 36 cases which it was not able to solve the cases in which duplicates are present. So we will be not following that approach. So uh, let's start. So let's first define length of these arrays. Okay, so first will be our brute force approach. What we're gonna do here is suppose we have these arrays. So this is nums1 array, this is nums2 array. So we will make a third array having size equals to n plus n, which will be our answer array. Sorry, let's call it merged array, whose size will be n plus n. So we will be using two pointers. One pointer will be here, another will be here. So which will suppose, so we will check which element is smaller. So here 0 is smaller, we'll put 0 in our merged array. Now we move our this pointer to this element now, which is smaller, 1 is smaller, so we'll add 1 to the array. So in this way we will uh, make our merged array as a sorted array, and we will return answer accordingly. So okay, so let's define first pointer and second pointer. So while our I pointer is smaller than n and our j pointer is smaller than m, we are good to go. So we will check if our nums of 1, if our ith pointer's element is smaller than jth pointer's pointer, we will add element at ith position in merged array. Otherwise we will add jth pointer, and in this case we will be moving our ith pointer. In this case we will be moving our jth pointer. After this, suppose if take this case 1, 2 and 3 and 4, 5 and 6. In this case our I pointer will move to end, but our j pointer will remain here and our loop will gonna end. So what we will be doing here is, while our I pointer, one of the pointer will reach the end first. Both pointers gonna reach the end. So we will check if while I is smaller than n. Okay, let's just maintain a variable idx which will be the pointer in merged array. So while our I is smaller than this, we will move I pointer. Similarly, we will do this for j pointer. If our j pointer is smaller than m, and at the end we'll check if our n plus m divided by 2 is not equal to 0, means it's odd. Sorry, it's not equal to 1. So this means not equal to 0. Okay, so this means our array is old and we only need one element. So we will return merged array m plus my 2th element. Let's see, 0 1, its size is 3, 3 by 2 1. Okay, so it's perfect. Otherwise we will be returning double of plus by 2.0. I think this will be perfect. Size is 3, 3 by 2 means 1. One, two, three, four. Okay, 1, 2, 3. Let's print our merged array. Okay, so our merged array is 113. Okay, we need to put nums2 here. I think now our code will work out. Okay, so in the case of two even numbers, we are having issue 1, 2, 3, 4. It is taking. So suppose this is our size of array. 1, 2, 3, 4. 4, 4 by 2 is 2. Okay, so we need -1 element. Four by two is 2. Wait a second. We need to put a bracket here instead of here. And now we need a -1 here. So this will work. Okay, so this approach is time complexity of this approach is a big of m plus n, because using two pointers we are iterating both arrays, so this will be the time complexity. But this is a brute force solution, so we need a solution which works in log of m plus n time. So we will use binary search. So let's comment this out. So in our optimized approach, we will find okay, suppose we have these two arrays, 1, 2, 5 and 7, 0, 3 and 4 and 8 and 9 and 10. And our so if we have this much element, 4 and 6, basically we have 10 elements here. So first let's just take a odd case. We have 9 elements. So if I form a merged array, 0, 1, 2, 3, 4, 5, 8, 9, 10. So this is our middle element. We need to return 4 in this case. So in the case of what we need here, we need an element from which our n plus m. So position of 4 is n plus m by 2. So we need a element from which n plus m by 2 elements are smaller. Okay, so we need an element from which here n plus m will be 9 by 2, which is 4. So basically we need an element from which 4 elements are smaller. Okay, means in total we need 4 elements, means some elements from this array and some element from this array. So suppose we take these 3 elements from this array. Now we have to take one element from this array. Okay, so we if we take 2 elements from this array, we need to take 2 elements from this array. If we take one element from this array, we need to take 3 elements from this array. So we need to decide that how much elements from one of the array we can take. Can we take 3 elements from this array? Suppose if we take these 3 elements from this array, we have to take this element. But if we take, then our array will have these elements 1, 2, 5, 1, 0. But we need 0, 1, 2, 3. So basically, we will be using a condition in which if this part, suppose if we take these 3 elements, we will make a cut here. So we will check if our this 5 is greater than this 3 or not. If it's greater than this 3, then our cut which we have made here is not correct, because we have this element which is eligible than 5 to take in the answer array. Suppose if we made a cut here, so we will compare 3 with this element. If we made a cut here, means if we take 2 elements from this array, we have to take these 2 elements from this array. If we compare this element from this element, so our 2 is smaller than 3. So basically we can take this part of the array 1, 2, 0, 3. So 1, 2, 0, 3. And suppose if we want to take only one element, then here we have to take 3 elements. So if we compare this 8, this 4 with this 2, this is our right part, this is the left part of this array which we will be taking after a cut. This will be left part of this array which we will be taking after the cut. So if we take this 4, can we means partition this array in this way. If we compare this 4 with this 2, so this 2 is smaller than this 4, so this 2 is eligible than 4, so we cannot make a cut. So what we need to compare is, wherever we are making a cut, we need to compare their left element with the second array's right element, and second array's left element with the first array's right element. So once I start implementation, the approach will be clear then. Okay, I will define the max number of minimum number of element I can take from a array, from the above array. So let's see. I can take 0 elements from this array if I want, and at max I can take max dot maximum of kl means. Okay, so we need a function which takes arrays as the input, nums1, nums2, and a variable k. Okay, so in the k we will be passing the middle value, that how much at which position we want our middle element, sorry, at which position we want a number. So we will be basically passing a middle position from here. So in the case of even, we need to call this function for two values, because we have two middle in the even sized array. So max of k. Okay, so max of k and n. Okay, so minimum of this and maximum of this. We will apply binary search while our minimum is smaller than max. We will define our left value as the minimum value. Then also our L2 value as this value. Similarly, our R1 value as integer dot max value, and R2 as so our mid will be so k is the number of elements we are taking from this array. If our k is 4, so that means we need to take four elements, means from both of the arrays. So mid represent the number of element currently we are taking from this array. Suppose our mid is 3, so we will be taking these three elements. uh, Mid is 3, so okay. If our mid is greater than 0, then our L1 will be mid minus 1. Means, okay, if our mid is smaller than n, means if our mid is 3, suppose, then we will be taking these three elements, then our index of R will be this. So our R1 will be equal to mid, which is smaller than n. Suppose our mid is 3. In that case, our R1 will be this value, 5. So we have found L1 and R1. Now mid represents the number of element we will be taking from this array. So k minus mid will represent the number of element we will take from this array. So if we take 4 elements from this array, so our k is 4, then we will take 4 minus 4, which is 0 element. So in that case, we will also define our uh, L2. So suppose we take three elements from this array, then we have to take one element from this array. So that index would be k minus mid minus 1. Similarly, if my k minus mid is smaller than m, my R2 would be k minus mid. Okay, so that is how we will define. Otherwise, suppose if our L1 comes this and we will not initialize, we will not fall into this condition and will not initialize our R1, then by default it will be max value. So it will be satisfying the condition that it is greater than this value. So this comparison will always be true. So we need to compare if our L1, means our nums of L1 is smaller than, if this L1 is smaller than equal to nums2 of R2 and n, R2 will be max in that case. Let's take these as the values. Okay, so if my L1 is smaller than equal to R2, and then my L2 is smaller than equal to R1, then I can say that current selection of numbers that we have selected mid number of elements from this array are correct. So in that case, what we will be returning? We will be returning the maximum value of this and this. Maximum will be maximum of L1 and L2. Okay, so nums1 of L1, sorry, L1 and L2. Else, if suppose I take these two elements from here, then it will be valid. This one element from here and these three elements from here. These three elements from here and this one element from here, then this will be my right part of this array. Sorry, this will be right part of my this array. So my this comparison will be failing. That I still have smaller elements in my above array. So if my R1 part is smaller than my L1 part, in that case I need to take more elements. Means I need to increase my mid1 values, otherwise I need to decrease my max1 values. I need to take less elements. In Okay, so basically this function returns is the number of elements which are smaller than this element. Means mm, for this array the shorted array will be 0 1 2 3 3 5 5 7 6. So if k here is 4, so that would mean that we need to find we will be finding this element. Okay, we will be finding element at the uh, what we will be finding, three elements. K is, suppose k is 5, so 5, so we will be, what we'll be doing is fifth. Okay, so if our k is 4, then we will be giving this element as the output. So we will be giving this element is as the output if our k is 4. So basically we need to 3, here we have 9, so middle element is 3. So in order to find this element, we need to put in the k 1 2 3 4 5, k's value as 5, then we will get smaller 5 elements, an index of the last smaller element in the first k smaller elements. So okay, we need to find n plus m by 2 plus 1 as the, we need to pass this as the k in the case of odd. Okay, so in the case of even, let's take 7 here, we need these two elements. Okay, we need these two elements. So our size is 1 2 3 4 5 6 7 8 9 10. So 10 by 2 is 5. Okay, so we will pass our k as n plus m by 2 to find for this n by 2 will be 5. So 2 3 1 2 3 4 5. So this will return, our function will return this value, and also we need to find, we need here two k's. First k will be this and second k will be this. Okay, so if our n plus m divided by 2 is equals to 1, that means it's odd element. So here we need to return find mid element nums1 array nums2 array, and in place of k we need to pass this value. Otherwise we need to return this function, that's this function plus this values, and at the end we will be dividing the values by 2.0. So I'm just clearing out the brute force approach. Okay, okay, we also need to define min. Okay, the minimum number of elements we can take. Suppose we have a smaller array. Smaller array whose size is smaller than k. Suppose our first array size is 5 and second array size is 2 and our k is 4. K is 4. So if we are taking one element from the array with the size 1, we need to take three elements from that array. But we can't take three elements. So at minimum we need to take how much element from this array. We need to take 4 elements. At minimum, we need to take 2 elements from that array. K minus m, I think. Okay. We are getting a wrong output for this case. This is the even case. Okay, so we have element 1, 2, 3, 4. So let's find out what keys are we are giving here. So for first call we are giving k as 2, meaning that 1, 2, 3, 4. We need a element from which which is at this position, kth position, second position, and one at the third position. So our k, we are passing correct keys. Okay. Let's find out what values we are getting. Today we'll okay. Let's find out what values we are getting. Okay, so we are getting 0 and 0. I think our code is reaching this condition. Okay, so let's debug our code. So first for this value, we are passing 2. So our min will be 2 minus m. Min will be 0. And our max will be 2. Okay. So we can take 0 or 2 elements from this array. We will check if our min is smaller than equal to max. Yes, it's smaller. Then our first mid will be 2 by 2, 1. Okay. We will check if our mid is greater than 0. Yes, it's greater than 0. It's 1. So we will define this as our L1. If our mid is smaller than n, yes, it's smaller. Mid is 1. So this will be our R1. Okay. Let's just write out L1 will be 1. R1 will be 2. Okay. We will check if k minus mid is greater than 0. K is 2, mid is 1. So 1 is greater than 0. So L1 will be 3. L2 will be 3. Similarly, R2 will be 4. No, we are taking, if our k is 2, okay, we are taking one value from this and one value from this, okay. So we will check if our L1 is smaller than equal to R2. L1 is smaller than, no, yes, it's smaller than equal to R2. If our L2 is smaller than equal to R1, no, this condition will not satisfy. So we will move to our next part. If our R1 is smaller than L1, If our R1 is smaller than L1, no, it's not smaller. Sorry, we need to check if our R1 is smaller than L2. Okay. So basically, I have watched the Striver's video about this approach. So yesterday, actually, this is a pretty hard approach to come up with. I was able to come up with a binary search solution, but that was failing on the duplicate part. So I think this approach is pretty good. Mm, these are two separate questions. This is a question in itself, means finding uh, the position of kth element in two sorted arrays. Let's try submitting this. Okay, great. Okay, so let's take a 5 to 10 minute breaks. After that, we will start with linked lists. This circular linked list. So in most of the cases, In 90% of the cases, we use singly linked list. So basically, if you know how to manage pointers, then linked list part will be very easy. Linked lists are just will be handy to you. So first we'll start with this question: reversal linked list. Then we will do merge to sorted list, and then we will do linked list cycles. Okay, so question is reversal linked list. So basically, we have a linked list. We have to reverse it. Or one pointer is moving on towards two towards three towards five. Then we are returning, or five pointer is moving towards four towards three, and two towards one. Okay, I have sold it three times. Okay, so my linked list structure has a field value. Value will represent the value of linked list, and a pointer called next, which will be this pointer, means the address of the next node, next link list node. So this is my constructor. These are my constructors basically. So we need to reverse a linked list. So we have this linked list: one, two, two pointing to three, three pointing to three pointing to four, and we need to return four. This is our input, and as of output, we need to return four pointing towards three, three pointing towards two, two pointing towards one, or we can say so. That's how we need to reverse the linked list. So what we will be doing here is we will be removing this pointer of 1 and will be attaching this side. Okay, and we will be somewhere storing this address of this so that we don't lost it in some variable. After that, what we will be doing, we will be moving this to's pointer. We will be deleting, we will be creating a pointer here and deleting this pointer. and storing this reference. Then we will be creating a pointer here and we'll be removing this part and storing this pointer. Then what we'll be doing, we'll be making another pointer and we have nothing to store, then we can simply return. So we will initialize a previous pointer as the null value. We need a pointer to previous part. So initially we don't have any previous part, so we will simply have this. Then we need a current pointer, which will be pointing at this position head. So we will be moving our head pointer while it doesn't reach the null value. Okay. So currently our current pointers, next pointer, current nodes, next pointer is storing this value too. But we need to move this pointer to our previous value. So before moving it to previous value, we will store it in a temporary variable. This will be our current or next value. Now our this part is stored in a temporary variable. So this part is stored in temporary variable. Now we can move our next pointer to our previous pointer. So now our this next pointer is pointing towards null, and our this pointer is stored in our pre temp part. So now we will move our current pointer to temp pointer. So now our current pointer is moved here. Okay, so our current pointer is here now. Now we will check our current pointer is not null. Now we will store this pointer in our next pointer. Wait a second. Current. We also need to move our previous pointer to our current pointer. Current pointer to next pointer. And at the end, we will return our previous pointer. I think this will work if I comment this. Okay. Okay, so we have reversed the linked list. But I think we can also do it using recursion. Means I can pass these variables in instead of using a while loop. I can use recursion, and when my previous reaches null in the recursion, I can return. So that would be same approach. Okay, so next question is merge two sorted lists. Let's open this. Okay, wait, sorry bro, I forgot to share screen. I forgot to share screen. So let's move to the next question. So next question is merge two sorted lists. You are given head of two sorted lists, list one and list two. So basically we have this list and this list. Okay, we need to return a third list which is sorted. Okay, so it's so first this pointer is pointing this list and this pointer is pointing this list. Okay, so we need to return a sorted list. So what we're gonna do is we're gonna initialize a node as the dummy node, new list node. What is the values of my the number of node in both lists are node dot value can be 100, so I'll initialize at the imaginary value -101. So this is my new node. So I'll attach rest of the my linked list to this dummy node, and I will at the end uh, return dummy dot next node. So basically dummy node will help us to initialize our sorted linked list. So while my list one is not equal to null, and my list 2 pointer is not null, I will move these pointers. I will compare if my list 1 dot value is smaller than list 2 dot value. If my list 1's current value is smaller, what I will do is I will simply okay, I can manipulate the same list and also create a new list also. So first solution we should write we what 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 to do. Let's decide क्या करना चाहिए इधर. हम बेसिकली एक नई लिस्ट भी बना सकते हैं और जो एग्जिस्टिंग दो लिस्ट हैं हम इनको भी वो कर सकते हैं मर्ज कर सकते हैं मतलब इनके पॉइंटर्स मैनिपुलेट करके एक दूसरे की तरफ पॉइंट करके और हम इन्हें भी वो कर सकते हैं. A का pointer B list हो गई. A का point will move his pointer to this part. Okay, so let's take a list node temp as okay. Let's skip this part. So then my dummy dot next will point towards list one. Dummy will point towards list one. A and B pointer. A pointer 4. Okay. Okay. Dummy pointer. Okay, I have initialized a dummy node and I will initialize a temporary node which will represent my which will represent my currently which will be pointing towards the dummy node. Okay, so I have this. So basically, I have created a dummy node and I have created a temporary pointer which will also pointing towards dummy node. So now my first pointer is list one pointer, second pointer is list two pointer. I will check if my list one pointer's value is smaller than list two pointer's value. Then what I will do is I will move my temporary pointers next towards my list one's pointer and will move my basically suppose here I have a temporary pointer, so I will compare this value and this value. So suppose this is smaller, let's put a check smaller than or equal to. So if this value is smaller than equal to, what I'll do, I will move my temporary pointers to temporary pointer to here. After moving temporary pointer to here, I will move this list one's pointer at 2. Okay, so I will move my list one pointers to next position, list one pointer to list one dot next. And if the case was opposite, then what I will do is I will use list 2 and move my list 2 pointer here at 3 position. Okay, so this is temporary variable. This is list one pointer. This is list two pointer. So then my temporary pointer will move to this position and list one will move to this position. That I will compare 2 and 1. So then my 1 will be smaller than the 2. Then I will do is I will move my okay, also I need to move my temporary pointer to next position. I think this will work. No, this is not working. Output is extra 4. Okay, what's wrong with this list? I have a point list. Okay, no pointer is initialized here. In this case, dummy pointer. Next one, list 2. Okay, so what I need to do here is Mm, if my list one pointer becomes null, then I need to point my temporary pointer this. If my list 2 pointer becomes null, then I need to move my temporary pointer to list 1, I guess. Okay, fair. Previous submission was in 2022. So this was some different approach. Okay, so we will now move to this problem, linked list cycle. Sorry, linked list cycle. So my last submission was last year, last year. So the question says, given head of a linked list, determine if the linked list has a cycle in it. So for example, this list has a cycle in it. So we are returning true. Also, this list has a cycle. We are returning true. This list doesn't have any cycle. So we are returning false. I think we can do is it using hash set. S- like there's a question which says return true if duplicate exists in array. For example, this array 1, 2, 4, 1, 5. So for this array, we need to return true or false. If any of the value is repeated two times, we will return true. Means duplicate exists. So here one is occurring two times. So we will return two. So we can use similar approach here. For example, if we start from this position 3, first we will add 3 to the hash set. Then we start from here 2, we have 2 in the hash set. Then we start from 0, we have 0 in the hash set. Basically we will not be storing values of the list, but we will be storing addresses of means address of 3, address of 2, address of 0. Then we move to next. -4 doesn't exist in the uh, hash set, so we will add -4. Then we will come to this value 2 again. Then we will check if this value is exist in hash set or not. So it is already existing. So if the address already exists in the hash set, we will return true. So for example, we will create a hash set of list node, and while my head pointer is not equal to null, what I will do is I will check if my set contains this head pointer. If my set contains this head pointer, I will return true, that cycle exits. Otherwise, I will add this pointer to my set and I will move to next pointer. Head dot next. Uh, okay. If I am able to, if my head becomes null, so that means this loop will end and I will return false, that no cycle is existing. So I think this approach will work. Okay, so this approach is working. So I think previously I have also used the similar approach. Yeah, this is the same approach which I have used previously. Okay, so this is a different approach. We will discuss it now. This slow past. Okay. Okay, so basically we can solve it using one another approach. So this is a brute force solution. We can mark this solution as the, please come on, as the brute force solution. So we have an algorithm named, that algorithm's name is higher tortoise approach. Tortoise. Basically, higher is rabbit. So in this approach, we take two pointers. First pointer is I pointer. Second pointer is J pointer. So like rabbit, this J pointer, in we will move it. We will increment every time by two. We will add every time two to it, and to J pointer every time we will add one. Its J pointer will be slow like a tortoise, so we will add one to it. J plus one means we will start from here. Let's, you will understand approach once we will start implementing. So we will start from here. Our, let's call this node. We will call our slow pointer as initialize slow pointer from head and also the fast pointer from head. So the algorithm says that suppose first my pointer is here. Let's take this example 3 2 0 minus 4. So initially my slow and fast pointer will be here. So after one step, I will move my slow pointer to here and move my fast pointer by two positions. So my slow pointer will be at second first index and fast pointer will be at this index. After that, again I will move my slow pointer here and my uh, fast pointer will move 5 and it will cross this loop and again come to 2. So my fast pointer will come here. Again I will move by 1 point, so my slow pointer will go here and my fast pointer will also reach here. So the concept says if my fast pointer and slow pointer meet, so then the cycle contains uh, the linked list contains the cycle. So while my slow pointer is not equal to null and I will check if my fast pointers next is not null, so that I don't access fast dot next pointer. If this is null, then I will be getting a runtime error. So I will be checking this condition. Then what I'll gonna do is I will gonna do move my slow pointer to next position and fast pointer to next position. So if my at the end my slow pointer, okay, so we also have to break the loop. So when my slow pointer and fast pointer meet, in that case my loop gonna break. So in this condition my loop will be breaking. So what I will be checking here is if my slow pointer is equal to fast pointer. In that case, I will return true that my loop breaked when my pointers met. Otherwise, there are two conditions when my loop gonna break, when slow is null and fast dot next is null. So in that case, there will be no cycle. So I will simply return false. Uh, let's see that solution, previous solution. Slow fast pointer. This was the solution, I guess. Yeah, I have used exactly same approach. So yeah, I think we can run this. Okay, so we are getting -1 position, -1 output true. Okay, so mm, this test case is failing because I only have one element in the list. So in the case of one element, if my head is null or head dot next is null, in that case I this means list have zero element, this means list have one element. So in that case it's obvious that there will be no cycle. Hmm, there can be cycle, a pointer can point to itself, I think. Maybe they are not using, so let's try returning false here and try submitting it. Okay, so fast point slow pointer is at head position, fast pointer is also at head position, moved slow pointer here and fast pointer to null. Slow pointer is not equals to null. Mhm, mhm, mhm. Slow pointer is here. Fast is also here. Moving slow pointer to this position. Fast pointer to null position. Mhm. Illegal start. Or we can start our head pointer on the next position itself. Okay. Hmm. Okay, missed this condition. First will gonna be null first. So what if I remove this condition? Why my test cases are failing then? For this case, 1 and 2, slow and fast here, moved slow to this pointer, null, output to slow equals to fast, how slow equals to fast here. Slow put value, slow is not head dot next. Okay. Understood. This will work. Okay, guys. So I think this was the last question from today. Yesterday we will try to solve all the medium problems from the linked list. Uh, no, I don't have any upcoming Google interview. Thank you.